Material science is, if you look at national needs, national interests, they're at the top of the list. You look at the top 10 research areas that they're going to invest into federally. Most of those are either material science overtly or implicitly. And so there's a huge national push. Regionally, this is a push as well, whether it's different industries, whether it's aerospace industries, computer industries, tech industries, those are also materials driven.
Material science undermines a lot of modern technology. So you go for a computer processor. The first computer processor, really the first large-scale integrated circuit, was basically in the early 1970s from Intel. And if you look at what they built then versus what they're building right now, it's astonishing. It was a few thousand transistors on a computer chip, and we're now measuring, in current technology, we're now measuring computer chips with billions of transistors. So the growth in all of the apps and materials thing, they learned how to take silicon and make it better and better and better, and be able to get more and more performance out of it, and be able to do more and more applications out of it. As we understand the fundamental physics of these things better, we can do more with it. Baylor's interest here is, we think we have a role to play in all of this, whether it's in composite materials for mechanical applications. Here in the Department of Physics, we're particularly interested in electronic properties of materials. What new materials can we develop to do new things?
Baylor is geographically exciting in a sense that we are really close to a lot of collaborators, a lot of very strong materials research that is happening in Texas. Now, what is distinguishable at Baylor is the fact that we are now doing science that has not historically been done before at Baylor, and there's a population at Baylor that would be very interested in this sort of work. And with our future hires, I envision that we can even do bigger science, but collaboratively. And I would say that most PIs in this area, that's what we do for a living. That's by definition what material science is. It's at the interface of chemistry, physics, and engineering.
What's kind of interesting about material science engineering is it's taken this time spectrum. On the one end, I have brand new physics that someday I may do something with. I don't know when that's going to be. To manufacturing engineering, which is on the shop floor, making real-time changes on making parts, components, things that are going out there to solve the problem today. Problem is, these two length scales are disconnected. We're in the middle right there is this material science engineering. It says, let's take this time scale, which is undefined in maybe years or decades, to this time scale, which is weeks or months, and let's bring it to a much more manageable time frame. Doctoral student comes in, a couple years for their PhD, that's the time scale we're looking at. So from a student perspective, you're coming in with this edge of someday this may be applied, and you're bringing it to and now we can apply it. So you are essentially developing the technology that can be used as you graduate.
What I envision is this material science program is driven by a group of scientists who are passionate about research, and that's what's driving the material science to move forward. And along with that will come the funding opportunities and also the opportunities for the graduate students.
Baylor has a unique perspective on this. Yes, we're really good at sciences, we're really good at STEM, and we're really growing in that area. Now being an R1 school, this is huge. But Baylor's unique in that we are a Christian university seeking to learn more about God's creation. And in my perspective, I'm just studying God's creation. And that to me is exciting. So I get to say, hey, this is a national need, regional need, industry need. And this is just learning more about God's creation. I mean, I feel that was our directive right out there from the Garden of Eden. Go forth, Adam. Learn the world, understand it, make it a better place. And that's where I see the material science coming in on all that.